All right. Welcome back. We just start. I'm gonna go through the agenda again. This is the second session of the disaster mitigation working group. With the first talk, we start with me. Then gonna be online for Basuki, Indonesia, and then Dr. Shiro Kawata from Japan. And the last presenter is Fernandez from EU, very far away from Europe. Okay, then quickly I'll try to go through my presentation. Just a talk, it's just an update. Okay? This is from the one big organization, Hydroinformatic Institute. What we have done at the ASEAN Hydroinformatics Center, but most of the slide is about this Upper ASEAN update of the fire and the smoke haze activity, the main one. So this she's not here. This Wildland Fire Special Research Unit is under this UNISER or UNDR, is saying we are part of this Southeast Asia. Sorry. We are part of Southeast Asia. The main one in Indonesia, Bogor University, that got the Professor Bambang got orders support from German government to do this, but they are all doing only peat fire. But Upper ASEAN, we have different vegetation type. That's why we have it, this unit. This unit in the Faculty of Forestry. So, but we work together. This is why geoinformatics get famous nowadays, and people can access information easy. Sometimes it's too easy. So it's just like you have to beware. Like I just discussed with Director France, that geoinformatics is just a tool. You know, you have to interpret. Don't think that what you get in front of the computer will be the final version. You need to understand the topic that you would like to say. Like forestry, you have to ask forester. For marine, you have to ask the marine scientists. Not the satellite, just the data. It's just a tool. So you still need this. The field validation very needed. That's why when NOAA or NASA launch any sensor, any satellite, they have a calibration and validation team to get adjust the data, adjust the sensor in the future, and see how correct it is. Like now, I just asking Winfred Schroeder that the NOAA 21 launched for maybe 4 months already. Just asking when the data will come out last Monday, because the Lao BDR would like to see it. I would ask that. And this is the paper that we try to fix or recommend about the new sensor when the NASA will launch it for NOAA, the future, the VIR version 2, second generation. So this is a group of us trying to do the recommendation to them. So this is from different scientists all over the world that doing the forest fire. And COP26 have a chance to combine this the community based. So we've been talking about forest fire, community based forest fire management for a long time. The idea that I have been working with the Hydroinformatics Institute for many years, so it's time to combine them together, the water management and fire management as the community base. So I wrote this piece of article, and it's launched before the COP26. And coming up, the chapter, 3 chapter, with Krishna is the editor. So this is coming up next month. So it's about active fire, and then the fire danger rating system that we have to be calibrated. We are talking after almost 10 years, we realize correct, but it's better than the one that ASEAN using. So we are talking with the Canada research, national research, to help out how to calibrate it more correctly. But we need to get the historical weather data from the Met Department by 30 years in the format that accepted by the Canadian fire danger rating system. So we'll see about that. But it's gonna take a long time because it's a free, so no money for it. So you have to find a free time to do it. And this is another one trying to understand the fire behavior, but the journal Rucker in German wrote this, but we did it in 2017 something. Because a big fire burned the whole wildlife sanctuary. So we can calibrate fire behavior software, match that using the satellite data, and then the field, the ground truth of the field. So it will be also another chapter of it. Like Eric said, I add more for the any disaster. We do the prevention mitigation now, the most important step, and we do monitoring satellite brands, prediction, forecast, modeling, saw it previously. We issue the warning, we respond, and recovery and mitigation that we need to do more now. And the last thing that I think is important, very important too, that you have to do after action review. So you know the mistake, fix it. But this process is very dangerous because the boss have to listen to everybody without getting angry. That's very difficult because if you have like a high ego in process, so you need to listen and fix and make it better, which is not easy to ask for some bosses because they're like, no, I said you have to do that. So this is the very important process that really need to enforce. For forest fire in Thailand, the government ordered to do it in the past, I don't know, in the past, let's say 7 years, 8. But in conclusion, the top guy, the minister, will, I want to do 1, 2, 3, 4. So that after action review throughout the country, not gonna help. Because this is what 1, 2, 3, 4. I said, like, because they gave me a call last month to do this another after action review. I said, hey, use the old one first. You don't have to do it again. You use the old this result from after action review to fix it first. Then you can move on, because even though you do it again, it's similar thing. And so that's just the process. So this to continue see later. It's just to show monitoring. And now IoT, we using IoT. So this is the project that AIT got it from Asia Connect, and that we are doing with the community up in the mountain. So the air quality sensor now, the low cost one, become a standalone in the forest. Okay, the problem is the connection, the how to make it online all the time. So far, after 2 years, good. So this is what it looked up in the mountain. And lately, and then they put the IP camera up on the top of the mountain, and they can find fire. As you see, you can see the smoke. They can find the fire, but they still don't know the location. But this is the community work. The people in the community doing by themselves. The IP camera they're using is cost only 1,500 baht, which is like let's say $35, and you can Let me show you. This is what he follow, and this camera can tilt and can go around. So he looking at. Uh, so this is like he looking from the village to up on the mountain, because it's even the motorcycle going on the ridge of the mountain take like 1 hour to go there. So he has to be sure that the what's going on in the area is really burned. So we are trying to do this. Dr. Banjai also got the project. So AI deep learning, and then machine learning detect the smoke, then we can keep it on. But the problem will be the location. The system is already there, but costs a lot. Okay? But now in the research, we try to minimize the cost down. So far, you can see it, but who's gonna watch it 24 hours, 7? No way. So you need machine to watch it. And then it's not here. This is the website that you can check. Yesterday we had the training in this room for this project. And this is, we decided to use LoLa extended by the to at the border of Thailand and Myanmar. Problem is that because Thailand always saying that the smoke comes from Myanmar, Myanmar also say that smoke comes from Thailand. So we decided to put, this is the army base. We just asked them to put the standalone system there, extended by LoLa. But you need line of sight, then that you can see. Hopefully this year, when we get the data, then the team of the other side, data analytic, and see is it true that the smoke from we have a bad air quality in Thailand, up north in Chiang Rai, is it from? We'll see about that. You can access it at this website in Thailand. Just very short down. What food of Thailand. And this is open data, but low cost sensor, and so you can download all the data since the beginning of the project. And this is what it looked like at another place. It's Mapping National Park, which is a lot of fire there. So we decided to do it there with the standalone also in the forest. This is like where we go. We have to go during the rainy season. So to install this 4-wheel drive cannot go, so you have to walk. This is what it looked like when you get the data here, and then you can go into the website and you can just click this open and change the date. You can do a little bit of see comparing different stations to see what's going on there. And this is the Banjai project that they're trying to do the similar thing that the Doi Chang Ba Pe, the villager, doing. So to detect the fire and tell where are the fire location. So it's ongoing. So far, still not give a good result yet. Maybe that what Dr. Dison said, which is maybe that the fire is happened behind the mountain. So Dr. Ken Murata, I hope he's here, but he's not, in ICT. He has a system, Raspberry Pi, that we already got from Dr. Shalom, just in his office, so we asked that. And the other one from Dr. Prapan that we try to put in the forest. But now the problem is that the system need Wi-Fi and 5G connection. So you need to change the code with inside, because when you go in the forest, it's only 3G or 4G. So that's the problem. So we have to fix the code inside and get the system. This is testing with the Wi-Fi, okay, but go into the forest is not. This is like all the data will send back to an ICT, because there's an AI system that can detect even the smoke from the garbage that burning further away, and they have the location. This system, Dr. Ken use it for monitoring the volcano. And this another one that we're trying to do the calibration and validation with the ECMWF Europe regarding the fire emission, different the PM2.5, the carbon emission, carbon dioxide emission. So it's ongoing. So they give. We got this. Massachusetts University and King College. Professor Martin Wooster, well-known scientist, got this fire emission. Provide us the sensor. The project for them is deployed in Vietnam a lot, not allowed a lot. But because I would like to get some for Myanmar, as I promised them, and I don't have funding to, so I asked him and he gave some on the way to Laos and Vietnam last January. So I gave 2 to Myanmar Forest Station and 10 in Thailand. And this is asking for more, but they will conduct it. Finally, they decided to conduct it in Laos, India. Try to get emission factor. You have to really measure it in the field. You have the equipment and to use the drone to collect the smoke inside the fire with different fuel. You have different emission value that you try to calculate to get the emission factor, and also you need to collect the fuel type, whatever fuel that's burning, and then do it burning in the lab and compare them to get the final result. So far, this is the type that they would like to do. So they're gonna put the sensor from the gas lab, and then with the drone, they said, "Now I'm in here. Our next week, Taiwan, they will come by Thailand on the way to Lao PDR. They will drop this somewhere, then when they come back, like try to find fire and collect the data for them to calculate to find this emission factor." Because the problem is that we're still using it, Thailand IPCC before value. So see the carbon emissions like that. Each species we need the specific one. So we need to collect the data. We cannot just sit in the room like this and say we have the emission factor 1, factor 2. It's impossible to do it. And this is long-time collaboration with Diane Davy at the NASA. Everybody knows about this. Everybody using this. It's a fire information for resource management system. Firms from NASA. Now they have more data from the Portuguese. The Martin Wooster put the Himawari. He used Himawari data to produce the active fire, but the system is in Portugal. So last year, January last year, we got the data, but I couldn't. You have to download it every day. Every 10 minutes to plot it. So eventually, lucky that Diane Davy also email. So she decided for the team to put the data in Perm system. So now we have. And this is from the man himself, Winfred Schroeder, who wrote the code. The problem that I asked him to do this system, another one, because this directly from NOAA, if you're using MODIS or you're using gears, NASA firm have a latency agreement, but the satellite is not belong to NASA, it's belong to NOAA. Okay, so NOAA can get the data information first. Then maybe after 1 hour, it used to be 3 hours, they release it to NASA. So NASA will distribute data 3 hours later than NOAA. So I asked Winfred Schroeder, can first start with Thailand and then now the whole ASEAN. Can we get the same data? I mean, it's active file information as same as US Forest Service. And he said yes. Then now it's down to ground station time process. So 50, 55 minutes and get data. And it's now covered the whole ASEAN, not only Thailand. And everyone's asking about Chris Elvish. Now it's a Colorado School of Mine and having this whole lab doing the night fire. So we try to validate it and doing the fishing boat. There's a monitoring fishing boat system that we use for marine protected area of the national park to detect if illegal fishing boat that come into the marine protected area in the national park. So give the alert warning that we know about it. The system is there, and he's doing it for the whole ASEAN as well. Just got this is another calibration one. Mark Collington asking that helping out. If anyone can help, just it's a project that they need input from the people that know about emission by emission. Yeah, this is the system I told you, forecast and early warning with the idea of build the group that put the weather forecast into the fire danger rating system, so you can have early warning system. And this system using the forecast data from WAP wrong for hydro informatics. So we do it every day. But need new calibration, like I said. Now we are talking with the Natasha, and the main guy, Mike Walton, is now the #1 guy for this. So this India too. So we hopefully get the better trace. So we can plan better in the future. And this is just the detail that what we are doing. The government of Canada, but only knowledge, no money. You have to find your own money and time. So they will help. And this is the result that we use. This is the data from a high from HII that doing forecast every day. So we pull that data and put into the system and can have this forecast result. We have done it for Upper ASEAN. We have it for Myanmar, Laos, PPR, and also Cambodia. But Vietnam, we didn't do it because they said they have their own. This is the sign that we put all over. The color might not make sense, but this is what ASEAN doing. So you have to follow them. There's still some that can do nothing, but that's already agreed. Unless you will change it at the ASEAN level to change the color. If not, we still have to use this color because it is what agreed in 2002. The system. So this is another experiment going on in the mapping national park. We have also that I realized that the result from fire danger rating system that we have is wrong, because finally we got the equipment, the fire weather equipment from Canada, test it out, and it's wrong. It's like what? But I just realized it around a year and a half ago, after looking at the station data. So we will fix it, but I know it's wrong. And we also have this training with the US Army doing the top up role. They have this, a fire expert exchange. Do it second year in a row now. So now they introduced the US technique. In May, we'll do it with the France. The France embassy, Sean, he would like to help support ASEAN. We've done it for Vietnam already, done it for Indonesia already. So this year, we'd like to expand to Thailand. We'll get the expert from France to train the French equipment how to suppress fire their way. So we try to integrate it. And then I already doing it for Korean for a service. So I put them together, and they have to work together and get this. Anyway, so we have this, another training for ASEAN. And this is the update that I talk about, and then we have a lot more. So HII, ASEAN Hydro Informatics Center, is moving forward. As you know, we have the theme, 5 themes, and we are now the chairman is Singapore. The white share is Vietnam. And we also have the product. This is the plan roadmap. And we have the product that's the contributed from Maori 9, from 8, that doing at the website, look for the rainfall forecast. And from Vietnam, and oh no, it's this is Singapore app. Down here, sorry, that's something. Okay. Conclusion at the end. So geoinformatics or everything is a power tool, like I said at the beginning, but it has limitations. So you need to be aware and understand it. Community-based level with the holistic approach is by integrating the indigenous knowledge with the current path. The wisdom is needed, and now it's accepted more and more. And people ignite the fire because of the problem, so we have to understand that. Climate change is real. It's not, I'm not calling it climate change anymore, it's a climate crisis. So it's a disaster, everything will get more severe, heavy rainfall whatsoever. And then you need to build this resilient sustainability. It's what we would like to do. The disaster, we cannot stop it, but we have to come back, have to survive. Okay? So we have to do that. We are in the different boats, but we are in the same storm. All hands on deck. Think globally, act locally. Imagine what we can do put together. Okay. And then the one for all, everyone. Thank you very much. Next. Any question? The floor.
Thank you for such a nice talk. Initially, you said that you guys are trying to detect smoke and you have installed IP cameras in mountains. So you can detect the system can detect the smoke, but not the exact location. So what exactly is the problem due to which you cannot locate that exact position? Because I think that you already know where the IP camera is deployed. If you integrate that information with something like Google Maps, the terrain information, you can have that box. Then maybe you can exactly pinpoint the that application.
That's the idea, but at least one camera cannot do it. And you need to have the cloud system, not just people. So the problem when you send the data like live feed, and at least you need two, like a firewatch tower, triangle to see the location, not only one. And with the terrain, you need to know exact location. If these suppression team going up on the wrong ridge, they have to go up, down, again. The accuracy with the expensive system now is like 100 with the two cameras. It's like the Indonesian government already bought with the 50. The result is quite good, but expensive. So we're trying to do it to reduce the cost, but still location very important. The US one from California Fire, there's a company that also 1 kilometer off. It's not just simply have the camera and then tell the location. That's the for the ship.
Just one more point, maybe a suggestion. I said that you have a guy who has to mount, and then he said all those ranges exactly pinpoint that location. You guys thought about integrating various your research you have with automated solutions. These HVACs have this 8 or 16 kilometers range.
They are using it, but with the battery problem, it cannot stay long. You can use it when you see the smoke taking maybe up with the thermal camera, you can see the fire from. But to see exact location, still the problem. It's not that that simple like in the terrain, in the forest. And the communication also. That's why yesterday that day when they have Lola expansion with the mountain of area, not that big. It's a blind spot that you can repeat. Install repeat. It's not that good location. Limited blind spot. Okay. You. Any further question? Okay, we can move to the second speaker is here. Basuki, are you there?
Yeah.
Okay,
Yeah.
the floor is yours.
Please stop your screen.
I already
Stop this.
I'm not in there.
Oh, sorry.
It's sharing from the room, so you can share it now.
Okay. Try this one, my slide. Okay. Can you
Okay,
see my slide?
see your slide. Please, the floor is yours. That's like, sorry,
Okay.
over.
Yeah, it doesn't matter. Okay. Sorry. Thank you, Eric, and many friends. Okay, this is my slide. So, I will.
Here we can see your slide. Please.
Okay. Okay. This is my presentation about the first night data analysis along Indonesian case. This is we try to have some preliminary for the data. Okay, this is my outline. Okay, this is background, the mission, and the target and data preparation, and we use right now using unsupervised learning. Sorry. Okay, this is the background. Okay, you see in the March on 2018 and March on 2019, we have a report from the Global Fire Watch. In the 2018 is around 700 fire alert around Indonesia on that period in the March until 15th of March. And the next years, and 2019, in the same period, almost same period, the fire report from the Global Fire Watch is more than 6,000 fire report around Indonesia. So that's the one of the things that you see in the many years ago, especially in the 2015, there is a very huge fire around Indonesia and make a smoke, and then this smoke is affected other country. That's the problem for us and for others. Yeah, so that's why we try to monitor what's happened around Indonesia. Okay, that's the background. One of the background of our observation. Okay, this is the other. There is some idea about we try to combine the satellite data and the meteorological record. Yeah, but the problem is we in Indonesia, not many have meteorological record, good meteorological record. And then even when we have some sensor, there is a problem with the operation with sensor. So that's one of the things that, and then maybe the next year or this year, the El Nino will come again to Indonesia, maybe. But until now, the meteorological situation in Indonesia are still changing. I mean, now it should be the situation. I know the situation. It should be the dry season. Yeah, but now we have yesterday we have so hot, and then now it's become rainy, I think. Yeah, now, yeah, rainy. Rain. There is a rain in my location in Bandung right now. So the climate is very changing rapidly. So that's the idea. Okay, sorry. That's my okay. One of the things that we want to have some monitoring the data, but the problem we didn't have so much capability even from the government itself. Government just have maybe 115 or maybe now it's become 200 automatic weather station around Indonesia. It's very difficult to get the data, and then the spread is not enough. So that's why we have a collaboration with the IT to spread the sensor, to monitor the sensor, the situation. And then it is not really working well. And then we want to have another monitoring system or another prediction. So we try to have we try to build a predicted model for fire from the previous location like the Sumatra Island, Kalimantan Island, Sulawesi Island, and Java Island. Sumatra and Kalimantan is become the most source for the fire in the forestry. And then the other target, like we have to try to find the pattern on the fire on the night. We try to find the pattern on the fire on the night time in that areas, like in the Sumatra, Kalimantan, Sulawesi, and the minor, Java is minor. Because usually we monitor, this is help from the Chris. We monitor the fire is come from the that area. Sometimes it's burned in the night, so we have to try to find the source of the source of the data, a source of the fire itself. Because when you see when in the fires itself, we can get the data not in the night. Usually in the mostly in the 14 hours. Usually in the data is taken just only in the evening. Oh no, in the morning or sometimes in the evening. And then the other things like we try to find the pattern using some deep learning or machine learning with the supervised learning and unsupervised learning and artificial neural network. Okay, this is the example of the fires. That's I think it's quite help for us monitoring using using the visible infrared imaging radiometers with fires. And then this data comes to satellite image with optical, and then we can actually the light is reflecting light into a single detector and 1 pixel at one time. That's very nice. And then this data is combined with the MODIS data, and it's AVRR. But we are using the data from NOAA and the NASA, and especially from the NOAA, we have fires, and then from the mines, Edu, Chris, we have update every day using for the fires night. The data especially capture on the around 2 a.m. in the morning, and then this the data daily update to our email, and we have to get some URL. Okay, this is one of the things, like this is a situation like we have used MODIS data. When I get this 2 weeks ago, not 2 weeks ago, one month ago. Actually, I tried to find the data from the NASA, and then from the fires, and then suddenly I surprised because not many fire in Indonesia. Not surprise in Indonesia, not many fire because this is still rainy day in many Indonesian area. But I don't know why, which your country, very tight, with so many fire over there. I don't know. Maybe still have so many fire. This is the data one month ago. And yeah, the first data is produced by NASA and NOAA every day, every region, up to 24 hours, and the resolution is 370 meter. And the data format is with using the KML and KMZ. Even there is a zip file and CSV file. And the data is just a parameter, location, longitude, and temperature and radiant energy. Okay, next. Okay, and then we try to have unique data with the first night. And then we have this data from the mines, from the this data is produced by Chris, yeah, I think, yeah. And then the first is unique, and then this includes the M7, M8, and M10 spectral bandwidth, and the nighttime M11. And then this data is available in 2017, and this we get the data in 2018. Yeah, this is for example, M7 is for this spectral of range of micrometer and primarily for aerosol, and M6 with cloud particle size, so no fraction maybe, and then M11 is clouds. And then when we get the first data in the night, I think we can capture first night with the temperature and radiant energy. And then this is daily update. Yeah, it's thanks for the mines to release the data. The data is very good and high use. And then we try to analyze this data using this first night data. Okay, this is, for example, this is the like Ferrachai in the one of this slide. There is the data, like for example, this is the data released in the 1 month ago for 14 February, and then we have some the data, the radiation. There is the data itself. There is a data geolocation, latitude, longitude, time measurement, temperature in the Kelvin, the temperature in that area, and the temperature of the background and the radiant heat. The data format is KMZ and CSV, and then this data is actually updated since 2018 until today. Yeah, we have to separate many things for this. And then one of the big work for us is to convert the data from the KMZ to KML, and then we sort the data. So yeah, okay, thanks for Chris works, and then we try to convert to KMZ to KML, because we want to have some CSV specific data, like the geolog, and then the radiant heat intensity. Okay, this is the structure of the data. Okay, see when the data release.
2 minutes, please.
Sorry.
2 minutes, please.
2 minutes. Oh, I have to find quickly. Okay, this is the structure of the data, and then the data have like this one. In the right one, there is the marking for the for the red is the area is the burn, or the node area is more than 600 Kelvin. It's very big. And then this is the KMZ data, and then we have to convert this. This data is produced every day. Okay, for example, okay, And then we try to have get the data structure in CSV, and then this is the CSV. For example, this is we every day there is a several data like Kalimantan Island, Java Island, Sumatra Island with the 6 row of the data. This is example for the 6 row. This is actually 41 rows with 116 column, but many column is not available. This is maybe something I want to ask to Chris to discuss about this data. Okay, for example, we try to this flag. There is a flag red, yellow, and then the longitude and radial intensity. Yeah. Okay, the format is this one. Okay, now the problem when the game set we have to pre-processing this data. For example, we pre-process with the time, location, temperature, source, temperature background, radiant intensity, radiant heat, and then source print, and then put in manually. I have to find manually, and then we have right now 30,000 row, and then 15 column of the data. Okay, and the target, we want to have like a predictive model for the some area, Sumatra, Kalimantan. Yeah, okay. With this data, for the and then we're running in the artificial intelligence with machine learning and deep learning, find the pattern of the data. Right, this is for example, we try to find with the unsupervised learning, with the unlabeled set, and then this is the some unsupervised learning with the using SOM, self-organized map, with a two-dimensional data, source, temperature, and radiant heat. Yeah. Okay, this is for the unsupervised. We try to running the with this supervised learning, for example, with the three-dimensional data, the temperature, radiant heat at the source print, because source of footprint. Because of the source of the footprint, we need to find where is the exact location for the next predictive model. Yeah, and then we will run again with the artificial neural network. Yeah, this step for this some area. That's maybe and then this future we still running with this, and then we use several mode, supervised learning for the dimensional data, temperature, source, radiant heat, intensity, and source print. The areas is Sumatra, Kalimantan, Sulawesi, and supervised. We try to find the anomaly for the anomaly detection, and we will use this data for the Minds Edu to train the dataset, our dataset model for the prediction area for the Sumatra, Kalimantan, and Java area. Maybe that's my update for this meeting. Maybe next event I will show the result, another result for this. Okay. Thank you. Thank you, Farida.
Okay.
Is there any question, please?
Well, later at the end, maybe because we have our
Sorry,
Please.
I cannot hear you.
we have to move to the next speaker.
Okay.
Dr. Kawakita, would you share your slide, please?
Okay, so good morning and good afternoon. So everyone, I'm Seru Kawakita of JAXA. Can you see me? Please?
Yes, but you need to share the slide.
All right, thank you very much. And so just a moment, I would like to share my slide on the screen. And Chai-san and Eric-san, and thank you very much for inviting me. And this is a good opportunity for Central Asia to share our work, and I would like the attendees to remember our work. So can you see my slide on the screen?
Okay.
Is it better?
Thank you.
All right. So once again, I'm Seru Kawakita of JAXA, Japan Space Agency, and acting executive secretariat of Central Asia. So today I would like to show, explain our work in Central Asia. So utilizing space technology for disaster management in the Asian Pacific region. So first of all, I would like to show the overview of Central Asia. So Central Asia is an initiative aiming at space-based international cooperation for disaster management in the Asian Pacific region. So this project was established in February 2006, and we are expected to implement not only the emergency observation, but activities covering the entire disaster management cycles. So as you know, so mitigation, preparedness, so pre-disaster response and post-disaster response, it means recovery phases. And so we are challenging for disaster risk reduction by collaboration between the space and the disaster management agencies. So this slide shows the membership status of Central Asia. So now we have 113 organizations. Since last year, so new members joined our Central Asia. One is disaster and emergency management presidency effort in Turkey. So as you know, the big aspect is the Turkey. So last month, and effort requested us to make an emergency observation and support. And so JAXA and the other space agencies so conducted the emergency observation of their satellites and provided the data to them. And some members, so including so universities and the national laboratories, and analyze the data and provides the especially the damaged building maps to the requesters and everyone on our website. And our another new member, so Philippine Space Agency, who joined Central Asia, so last January. In Nepal, so we have several members, Survey Department, DHM, MTC, the WIDM, and the International Organization, and Ishimoto. So this slide shows a emergency observation review by a geographical distribution. So since establishment of Central Asia, we have received over 400 requests from our members. So in Nepal, the total number of emergency requests is 24. And so I would like to show you our website on the page. Just a moment, please. I changed my sharing the slides. And I show you the website of Central Asia. Can you see my web browser? I hope you can see the my slide. So the Chrome site. So this slide, website shows you the Central Asia portal site. As you see, so you can obtain the many informations. So of our activities, one of them is the emergency observation. So in Nepal, for Nepal, yes, we have received several requests, as I mentioned earlier, totally 24. 2021, the flood one site in Nepal, and in this case, DHM requested emergency observation on the spot to Central Asia, and the JAXA conducted emergency observation of our satellite, ALOS satellite, and other space agencies, VISTA and the space agency in Thailand, and ISRO, so in space agency in India, and provided the data to the requesters. And some members, probably the ISMODO in Nepal, analyze these data and provide and so Vietnam inundated area or the spot of the landslide, estimated spot of the landslide. These information are shared. So with DMO and other agencies in Nepal. Okay, so go back to my slides. Okay, so this slide shows I'm sorry. So this slide shows contributions to data provider nodes. It means space agencies. So Sentinel Asia, we have 8 space agencies, research institute, currently contributing to emergency solution. So JAXA in Japan, MBRC in UAE, and FIRSA, as I mentioned earlier, in Philippines, and CRISP in Singapore, SDA in Vietnam, and DISA in Thailand, TASA in Taiwan, and ISRO in India. So if necessary, so you can request, so we can escalate emergency observation request to the international charter through Sentinel Asia. So this slide shows the workflow of the emergency observation. So if a disaster happens, so our members and the request is the Sentinel Asia to activate our work. And so ADRC, Asia Disaster Reduction Center, received the request and checked and confirmed it. And after that, so ADRC announced the activation of Sentinel Asia and request emergency observation or the analysis of the data to provide the disaster assessment map. So DPM, it means data provider node, including JAXA. So we conduct emergency observation and provide satellite data to the Sentinel Asia servers. Is located in Academia Sinica SCGC in Taiwan. And the data analysis node, so it means national laboratory, one university. So analyze provided satellite data, and so built on affected area by the disasters. So Sentinel Asia provides analyze disaster information to requesters, and most of them are open for public on our website. The tool developed for Sentinel Asia emergency observation requests. So Optimus, it is a support tool to make an emergency observation by our members. So this is has been developed by Nagista and is a web application with user-friendly interface. So managing the data regarding EORs. And SFTP is provided by the TASA, so Taiwan Space Agency in Taiwan, and Academia Sinica with computing. So external organizations supported us, and is a cloud storage SFTP site and storing the emergency observation data and analyze disaster assessment maps. This shows one example on the generation of action-ready information, a flood case in the Philippines in October 2022. So this slide shows the observation image of ALOS satellite. ALOS is a satellite, but it's from this image, it's so hard and difficult to obtain the affected area by heavy rains or monsoon or typhoons. And so some of our members, in this case, GIC AIT, so Asian Institute of Technology in Thailand, so analyze that pattern data and provide the flood detected the flood map, the areas, so in Philippines. And so this variable information was the public in our website, and then not only to the requester but also to everyone, and everyone can download this information from our website. And the next tool, so we have developed the WebGIS. So it means that web-based geographical to information systems. So this is very important, powerful tool for the requesters and users to obtain the important information from our website. This slide shows one example. So we response from the AFAT or in Turkey. So in the case of the big earthquakes, so in Turkey, so last month. So this tool is to help the emergency observation requesters and gather geographical information of the disaster areas. I would like to demonstrate these applications on our website. Okay, so go back to the web portal and emergency observation and earthquake in Turkey. Right, so you can, as you can see, so there are many damage assessment maps on our website, and TASA, so Taiwan Space Agency, provided the important information, and we shared all of them on our website. And so these applications I would like to show is a good example to use WebGIS. So which operated by the JAXA. So you can see that these applications on the website, so by everyone. So after this conference, if you are interested, I would like you to check our website and to browse our applications. All right, focus on the area. So let's indicate severe damage caused by the big earthquakes. The yellow estimated the red winner, so lower damage by earthquakes. And ground of the base map on provided through an OpenStreetMap, and you can change the base map on this. Click on the button, and you can see one big city. So you can see in a red area, the yellow areas, and so unfortunately, such as buildings are estimated to be damaged by earthquakes. Okay, so let's go back to my presentation slide. Right. And this is another example. So floods, in Taiwan in August 2018, in the TASA, requested the emergency observation, and our members, just Space Agency in Thailand and India and JAXA, and provided satellite data. So AIT, analyzed the data and provided they estimated the flood area maps to the TASA. This is an example of earthquakes in Taiwan in September 2022, so last year. So TASA also requested the emergency observation, and 3 space agencies provided the data, and one space agency, NBRSC, analyzes these data and provides the affected area on maps caused by earthquakes. And this is another example for interacting with JICA. So some people, as you know, JICA. So JICA is a Japan International Cooperation Agency. So it's implementing the agency for Japanese Offshore Development Assistance. And regarding the disaster management field, JICA implements the project and ONA dispatch long-term experts to disaster management organizations in developing countries. That we, especially the JAXA, is collaborating with the JICA and discussing how we can assist the country or the emergency DMOs caused by disasters. And we try to understand the impact of disaster and decide the priority of the field survey areas and make plans of reconstruction after disasters, etc. And the JICA actively uses our disaster information and provide concrete feedback to Central India. And so JAXA and other members will be shared this important information to our members, the Central India members. This is one big relatively great video to understand the Sentinel activities. After my talk, I will write down on the web link of the YouTube site on the chat box. Please watch this video. And next slide shows the flood in Pakistan in August 2022. So PDMA, so Pakistan, so provincial disaster management and other members register emergency observation in TASA, register ISRO and JAXA and the many space agencies. So provided satellite images to Sentinel. And JICA is the direct flood water information to monitor the impact of flood and to consider potential assistance to Pakistan. But not only JICA and other members, NPO, NGO in Pakistan, and the UN rating agencies, UNWFP and other members, so asked us to share these informations on the website. And then we opened the WebGIS application on our website. So if you are interested, please visit our website. So after this conference. And in this case, some agencies, JICA, expected statistical information. It means they can obtain the information such as the number of the damaged buildings or the number of the affected people in the damaged area. So as you know, it is relatively easy to estimate these numbers. And the JICA created some example and shared it to the JAXA created some example to JICA and they recognize. So this is very important and powerful tools to understand obtain the current situations and in the foreign countries. So other examples of volcano eruption in Indonesia. So to almost 1 year ago. So also JICA requested it. And so JICA long-term experts supported this operation. So using by the information provided by Central Asia. So in this case, EOS, Earth Observatory of Singapore in Nanyang Technological Institute in Singapore. So they shared, analyzed the product and one optical satellite data from APAN55 by TASA, and we can set this information on the WebGIS applications. The JICA found potential landslide risks, and they was hard to acquire from the field survey. And based on these information, JICA and some expert in Indonesia made a plan to make the field survey to react to this disaster. The earthquake in Indonesia in November, last November, and you have also the same situation. And the volcanic eruption in Tonga, in January 2022. And other examples, volcanic eruption in Tonga and also. And this is one good example. Establishment of the standard operating procedures, SOPs. This is one of the activities in preparedness and mitigation phase. For prompt and smooth URs to Sentinel, Secretariat established some standard procedure operating procedures, SOPs, in the below countries and regions: Cambodia, Thailand, and Nepal, Laos, Vietnam, and some regions: Central Asia, Caucasus, and Pacific Islands. We collaborated with some DMOs and international organizations to create these important SOPs. And based on these SOPs, some members located the Sentinel to make an emergency observation. And we can, JAXA, providing the global satellite mapping of precipitations. It is named GS maps. And some members refer to the information on the GS map and request the observation to Sentinel. And it's so easy and real-time provision of local information on the disaster via web-based mobile application and developed by an AIT. So this is just an example. And to validate accuracy of disaster information and provided by the Sentinel. So very important. So to feedback to improve our operation and technologies on DEMs. So university or national laboratories. So finally, I summarize my presentation. So Sentinel has received over 400 emergency observations. So since the establishment in 2007, and we are expected to implement not only emergency observation. So today I showed some examples and mitigation or preparedness. And so we try to make some ideas to request to assist recovery phase so to our members. So as one of the members, so JICA, so activity leveling sharing their feedback and promote the use of disaster information provided by Sentinel. So that's the end of my presentation. Thank you very much for your kind attention. Thank you.
Thank you very much, Dr. Kawakita. Any question from the floor? Yes.
Yeah. Said like these lights are being used for the imagery. So is it a plan for you guys to use the satellites for the communication, like networks during disaster communications?
So I'm sorry, I can't catch up with the questions correctly. If you have some questions, please chat your question on the box. I will answer your questions after my presentation. Sorry.
All right, and then you stay in and look at the chat. You type in.
Okay.
Any further question from the people online? If not, thank you very much, and we move to.
Okay, thank you very much.
Yeah, Fernandez, Eno Fernandez. Please.
Yeah,
share your slides and then.
Yeah, I'm going there. So thank you very much for having me here. Let me try to share. So can you see the slides?
Okay. Yeah,
Perfect.
the floor is yours. You have 20 minutes.
Okay. Yeah, thank you very much for inviting me to this talk. This will be a bit different from the previous ones. It's more a generic service that we are developing at the EI, and how we are trying to support reproducible open science with these two services that we have, the EI notebooks and Reply. So I don't know how familiar are you with EEI, but just one slide or two slides on EEI. EEI is a federation of computing resources in Europe, and the idea is to be able to support any kind of research with the best that we can offer computing services. And we deliver this as a federation of the different countries in Europe that come together in EGI, and we have let's say a coordinating body which is sitting in Amsterdam. This is the EGI Foundation, which is where I work, and we coordinate the whole federation. And in this EGI Federation, we have a set of services. We have cloud computing services, high throughput computing, several storage services, and we are also looking or developing services in more higher level layers, more user-oriented. That would be these notebooks and Replay. EGI does not just work in Europe only. So you see here the map of the countries that are part of our of our council, our constituent members, but we also have memorandum of understanding with other partners all across the world. We have them in let's say Middle East, in the Americas, in Africa, and we also have in the Asia Pacific. We have a memorandum of understanding with China, several Chinese institutions, and Taiwan with Academia Sinica. That is our main partner in this region. With these MOUs, what we are trying to set up is collaboration areas between the different institutions and initiatives, and try to basically broaden what EEI does to the rest of the world, trying to collaborate to improve our services. So that was my 2 slides introduction to EEI. And let's go to the main topic, which is this reproducibility in with the EEI services. So first, one introduction to reproducibility. What does it mean? So normally, what we want to achieve here is, one, you deliver a result in a publication. That's very nice. You showed that you have done something. But if someone wants to come later and check what was done and try to reproduce those results, the publication only is not enough, because you don't know exactly how it was done. In the publication, you just have the final result. So probably you will need some code for a computer to be able to execute exactly what was done in the publication. But code only, of course, is not enough. You will also need some data that was used to generate whatever it was generated. And even having those two may not be enough, because you have the code, you have the data, but if you don't have the right environment to run that code and use the data, probably you will not be able to execute. Let's say you don't have exactly the same compiler version, or you don't have the same computing architecture, and things will just not work. So probably for full replication, you also need not just the code and the data, but also an environment with the executable that will allow you to just reproduce everything. And what we are trying to provide is this whole thing. So somewhere where you can put the code, you can access the data, and you can create an environment for executing that code and accessing the data that it's the same as the original one that was created for the publication. For that, you need kind of all of these things that are in these slides. So you need the computational tools and interface to facilitate coding and creating the code around it. For here we are thinking on using Python or Julia, which are very common language in the scientific area. And there is a wide ecosystem of libraries for doing that. And we're thinking on Jupyter as the interface, which is a friendly interface that you can access from the browser. So that's kind of the environment where we think we can facilitate the reproducibility of previous work. All of these come together in a notebook, which is a document with text and code and visualization that can be used to communicate your work. So it's a comprehensive document where someone else can go and understand what's going on. With those two, you have kind of what you want to reproduce, but then you need where to reproduce that. So a way to execute your code and access the data. And that's where the EEI services come. And here we have a service called EEI Notebooks, where we are able to support the execution of notebook documents in EEI resources and potentially others. And then once you have that, you want to share it and make it available for others, and also allow them to reproduce. And those are the 3 last bullet points. So a way to share your work. We have things like GitHub and Zenodo for sharing the code and the whole thing that's needed for the research. A way to package for replication, that means how to create something that will be the same now and let's say 5 years from now, and will allow you to execute exactly the same code in the same environment. And there we are using containers, Docker containers, with a technology called Binder. And we have the EGI replay, which is a service that just delivers this binder. And also you need a way to persistently identify it so people can cite it and find it. And for here we are using DOIs and mainly relying on Zenodo capabilities for this. So I will show a bit of all of this that's in the slide in the coming and the forthcoming slides. So starting with Jupyter, I believe most of the people is already familiar with Jupyter. This is an open source web application that allows you to create notebooks, which are documents that contain code, equations, visualization, and text. And basically, you can use it for almost anything. It's quite nice because it's an interactive thing. You can just write the code and execute and see how it goes. It allows to have documentation. So, I mean, the typical ones are the ones I mentioned before, the Python, Julia, R, that others are supported, and you have nice outputs with graphs that you can even interact and do stuff with that. So this is the thing we want to reproduce in EGI, a document that is self-contained, where we have the code that is able to create the results of a given research. And for that, we have what we call the EGI notebooks, which is a service that hosts Jupyter in the EGI cloud. This is basically, you go there and it's software as a service. You don't need to install anything. You just go to the page, click on logging in, and you will be able to start using it. The main things that we have here as a differentiator of the EGI offer is that you log in with the EGI check-in service. That means that you have an EGI identity, and with that, you can go to other services to interact with the EGI infrastructure. So you can use storage from EGI or computing services from EGI very easily. What you have is a persistent storage, so whatever you put there will be kept since until with no limit time. And as I was saying, you can use the resources from EGI to run your notebooks. The service is online, and it's quite nice as an integration point towards other parts of the infrastructure. And here I show some of the things we can use from the notebooks. So it runs on EGI cloud and online storage services. It uses check-in for authentication and potentially accessing other services. We use CVMFS as a way to make software available in the notebooks. And thanks to CVMFS, we have access to the workload manager, which is a system that is able to submit jobs to high throughput compute service of EGI that's mainly giving you access to more than 200 computing sites all across the world. And we have also access to other storage system like Data Hub or the B2Drop from that. So notebooks is a nice place where you can hook other services easily and make them available for running your computation. For getting access is quite easy. You just get an EGI account that's going to ai.egi.eu and enroll in one of the supported BOs. And well, BOs, if you haven't heard of it, is how we call the groups in EGI. We have some of them, and one that we have specifically for the this disaster mitigation group is this vo.environmental.ei.eu. I have a link to share. Maybe I can put it later in the slides for you to join here. So you can go there, ask for access, and you can just go to the service. So this is a screenshot on how it looks once you log in. There is a link to join this VO, you click begin, just accept the conditions of access, and it will be approved, and you will be having access to this service. The notebooks also allows for a lot of customization. So we are offering several flavors or computing environments. We have a default one that includes Python, R, and Julia, and Octave, and also RStudio. But we also have one with MATLAB that may be interesting for some of you that rely on MATLAB. But we can also do very specific setting for any community. So for the system mitigation, we can have specific environments with your libraries or your configuration just to match your needs. And here you can see, for example, we have one environment for Reliance and another for ISCAP. These are communities that we are supporting with this service. And if you are part of any of these communities, you will see these options. So this can be done also for the environmental VO that I was mentioning before. So if you have a specific needs, just talk to us and we can set it up for you. For accessing data and code that is not directly available in the service, we have several options. You have the home where you can upload any file. We have right now a 10 gigabyte limit, but again, we can tune this to the needs of every community, and you will have those files kept even if the notebook dies. So if you come after a month, they will still be there. Then we have the Data Hub, which is an EGI service that allows for distributed access to storage resources. And we have what we call spaces, and every space will be able to manage their own data as they like. So you can basically store any kind of data here, and it can be as large as needed. And you can even access assigned PIDs, so a DOI, for that data, so it's easy to cite it and use it for reproducibility. We have P2Drop, which is another service from another initiative called UDAT. It may be interesting if you are aware of that. We have CBMFS for storing software, but also small data could be stored there. And we also have one thing called the MB Git Pooler that allows you to take anything from a Git repository, which is convenient to share also code. If you have your Git repository with your code, you can just pass a link to someone, and with a link, they will just get the whole thing in the notebooks environment automatically. No need to worry about how to make it happen. So that was a bit the notebooks environment. This is what we think people can use to create their research, and now thinking on how to share once that's done and make it reproducible. And that's where the Binder part comes. So Binder is an open source web application also done by the same people of the Jupyter organization. So they work quite nicely together. And the idea is that this allows to create an artifact that will be always the same from an existing repository. An idea, we have this diagram here. You have a researcher that does experiment, creates a notebook with all the code and text and visualization, and the researcher puts this code in a repository, GitHub, for example, and with not just the code, but also the dependencies of this code to ensure that it will be always the same. And with Binder, what it happens that Binder is a repository and creates a Docker container from that and makes it available for someone else. And that's what we have in what we call the EGI Replay, which is a Binder service hosted by EGI. Again, offered as a service with the same access condition as EGI notebooks. If you already heard of Binder, I believe you are familiar with the MindBinder services. This is basically the same, but adding a bit of more capabilities, more resources behind it. So it's capable of using any Binder compatible repository. and it has access to the EGI data. So for example, if you have analysis that's using the data hub and the notebooks, you can also reproduce it in this replay easily. And we don't have any hard limits on session duration or the resources that you can use, which if you have used MyBinder, sometimes it's a bit complicated because your session expires very, very quickly. So in this case, we don't have that. As a difference also, we require people to log in, which may not be the most convenient, but that's a way we have to control who can access basically. So when you go to Binder, you will have something like this screenshot, and I will show you later exactly how it looks. So first, what you need is a repository, a Binder repository, which is a code repository that contains what you want to reproduce, so the notebooks, a description of the software runtime needed for running those notebooks. For example, you can use a conda environment, which is quite convenient. Here, this is an example that we will use next week in the ICC for a training. So here we have this quick start GeoPy IPMB is the notebook. So what we want to reproduce. The environment.yaml is the conda environment. So all the libraries that are needed to run this notebook, and some auxiliary files that are needed for the analysis. It's very small files with data, or it's more than that, is the location of the data. So all of this is taken it's taken by Binder and created a Docker container that will be reproduced. And for making this citable, the idea is that we are using Zenodo. Zenodo is a repository for open data and open code, and Zenodo allows you to create an entry from any GitHub repository. So basically, you see here we have Zenodo interface with the GitHub part. You can select one of your repositories, click on the on here, and it will create an entry like this one. So this is one that I created some years ago. This is it's called EGI Foundation Training Notebooks C.NET. You see here all the notebook, the environment similar to what I was showing before. And the nice thing is that you will have a DOI. I don't know if you can see it here on the right. And that DOI can be used in any publication for citing your research. And then you can go with this DOI to the replay service, add it here to the form, click on launch, and this will allow you to reproduce the research. So overall, what we are trying to create is this kind of workflow. So we have a researcher that performs some data analytics and visualization with notebooks. He or she accesses data in the data hub, so can access a large amount of data. Once the researcher is happy with the results, goes and publish all the code in GitHub in a repository. With that, goes to Zenodo and create a DOI for the publication. That DOI can be cited in a paper, so people can just find it. So all the researchers read the paper, say, this is interesting. I see it has a notebook for reproducing it, and it has a DOI, so I can go to Zenodo and read a bit about it and understand that this is something that you can use in Binder or replay. Just go with this DOI to replay and recreate everything and reproduce analysis. So we want to support this kind of workflow and in the EGI services. So just to finalize, the services are up and running. You can go and start using them. I will share these slides and add the link to this VO environmental that we have. That's meant for supporting your community. You can go there and access, and we have 2 opportunities to show you more on this. Next week in Taipei, we will be in the ISCC. We have on the 21st of March, we have a couple of sessions devoted to showing you this live, and we will have also the EA conference in June in Poland. You are all invited to go there, and we can talk more about all these activities. And this is basically all I have. So thank you very much.
Thank you very much.
Is there any specific requirement for access for EGI notebook?
No, there is. Well, we just want to know who's accessing, but we are not requiring anything special. So what you need to do is just go to maybe I can just, since I'm sharing the browser, you can go here to notebooks.eei.eu and click here on continue with EEI check-in. This will open the login page. Since I'm already logged in, probably I just click. You will not have the same experience. You will probably need to go through there is 2 steps. First, you need an EEI account. So the first time you access check-in, you will be asked to fill in your name. And the second is enrolling to one of the supported VOs. We have this VO notebooks.eei.eu VO, but we have this dedicated one, the environmental one, and I can just share the link with you in the chat.
In the chat, maybe,
yeah. So let me find it.
Yeah, because in Indonesia, many people using the Jupyter notebook, including me. And then we try to. Usually we use Google Colabs or install Anaconda in the local.
Yeah, Google Colab is a nice service indeed.
Yeah, but sometimes they have a limited library, and then sometimes it's difficult to
yeah. So the link to join this BO environmental.eei.eu, it's in the chat. And if you follow that one, well, if you click on begin, you will. I'm already a member, I think. I don't know if it will ask, but basically you need to accept the terms, and someone will approve.
If there is no, there is no institution here like me in ITV, there is no connected directly. This is how we can access, or we can use just Google Colab.
Yes,
Google.
You can use a Google account. Yeah,
Google
that's
account.
not a problem.
Yeah, because one of the problem when we check like for this one, like we see Institut Teknologi Bandung, there is not in the list.
Yeah, Google account should work. And if you are interested in having your institution in the list, we can also talk about that. So
okay,
yeah,
I think.
But okay, please just try to join the environmental video. Otherwise, join the training this way.
Yeah.
Mm-hmm.
Thank you, Eric. Because I want to I want to know how to register as an institution. Because when we can register as an institution, so many maybe we can socialize to other researcher in Indonesia to.
Yes, that's great. Please just follow what Enzo training in here is the website.
Yeah, sometimes sometimes we use the LinkedIn or archive. Yeah.
Thank you, Enzo.
Thank you.
I think the EGI, the environmental VO is what we access and make use right now over the cloud services. And actually, what Enzo mentioned, very good reference is we are aiming to reproduce our listening to share the truth of our listening. That's a very good reference.
which is available right now, and also to be a good reference of the data sharing on the APAN communities. Thank you so much. So that's a very good way to join the detailed training of ITC these services. I'm for lunch.
Okay.
I'm sorry.
I can follow online.
Yes, please.
Jai, I cannot hear you. Jai.
Thank you so much, and all for your time in early morning.
Thank you.
Thank you. Thank you, everybody, for your participation.
Thank you.